All right, let's dive right in. We're going to pull back the curtain on something that's, basically everywhere now: generative AI. We're going to get into the real nuts and bolts of how these models actually build sentences, literally one word at a time.
So you've definitely seen an AI write something, and it just feels like magic, right? But it's not. There's a really fascinating process going on behind the scenes, and the big question we're tackling is this. When an AI starts a sentence, how in the world does it decide what single word should come next?
Because really, that's all it is. When you strip everything away, a large language model is just a massive, incredibly powerful prediction machine. I mean, it's trained on billions of texts, and its entire job is to look at a string of words and just guess, calculate the odds, really, for every single word that could possibly come next. So, let's get into what I'm calling the prediction game and see exactly how it's played.
Okay, so the most obvious way to do this is just pick the winner. At every single step, the model looks at all the possible next words, finds the one with the highest probability score, and just goes with it. Sounds simple, right? Well, this leads to a huge, huge problem.
And that problem is what I like to call the repetitive robot. It's this trap that models can so easily fall into if you're not careful. Now, this super simple strategy, it has a technical name, greedy search. And it's called greedy for a reason. It's because it always grabs the best immediate option, the word with the highest score right now, without thinking at all about the bigger picture or where the sentence is going 3 or 4 words down the road. And this visualizes the problem perfectly. So, starting with the word the model sees that nice has the highest probability, a 0.5. So, it just locks it in. It doesn't even consider that the path starting with dog, even though it had a lower starting probability, might actually lead to a much better, more interesting sentence. It just gets stuck on that first best guess. And this shows you exactly what happens. On the left, you see the code for greedy search. Super straightforward. But look at the output on the right. You ask it to explain AI, and it just says, I think it's a very interesting concept, over and over and over again. It gets caught in a probability loop and literally can't escape. This is useless, and it sounds nothing like a human.
So, okay, clearly just picking the top word every time is not the winning strategy. To get that rich, creative text we're looking for, we need much smarter ways to write. And the real key, the secret ingredient, is to introduce a little bit of, well, controlled chaos. Instead of just grabbing the number one choice every time, what if the model could sometimes pick number 2 or number 5? It's this careful balance between sticking to what's probable while allowing for a little bit of randomness that makes AI text feel creative and, alive. So one of the first smarter strategies is called top K sampling. It works like this. You set a number. Let's call it K. We'll say K is 50. The model calculates the probabilities for all the words, but then it just throws away everything except for the top 50 most likely options. From there, it just randomly picks one word from that smaller, much higher quality group. And you can see exactly what's going on here. The model generates this huge list of potential words, but top K acts like a bouncer at a club. It creates a short, exclusive list of only the most plausible options. This is great because it stops the model from picking some bizarre, super unlikely word by accident while still giving it some variety to choose from.
Okay, so what if we could make that short list dynamic? So it changes size depending on the situation? Well, that's the whole idea behind Top P, which is also called nucleus sampling. Instead of a fixed number of words like 50, you set a probability goal, say 95%. The model then builds a list of the most likely words that, when you add up their probabilities, hits that 95% target. And this is where it gets really, really clever. Look at this. If the model is super confident about the next word, like after the car, the word drives is extremely likely, then that pool of candidate words is going to be tiny. But if the context is way more open-ended, the pool gets much bigger, which allows for more creative and surprising words. It literally adapts on the fly. And the effect of using these sampling methods is, well, it's night and day. The model breaks free from those boring, repetitive loops and starts to write text that is way more interesting and nuanced. I mean, just listen to this example that was generated using Top K sampling. It's coherent, it's introducing a pretty complex idea, and it flows like a real sentence. It's a universe away from that repetitive robot we saw just a minute ago. And here's another one, this time from Top P. Again, it's a thoughtful, well-put-together sentence. It's actually building an argument here. This is the kind of writing that makes these language models so incredibly powerful. So, you've got all these different ways to generate text. How do you pick the right one? Well, it all really comes down to a classic trade-off. This table breaks it all down beautifully. On one end of the spectrum, you've got greedy search, fast, but as we saw, zero creativity. Then, on the other end, you've got top K and top B, which are awesome for creativity, but you have to tune them just right so the text doesn't become nonsense. So the big takeaway here is that there's no single best method. It's all about picking the right tool for the job you're trying to do. So why did we just spend all this time geeking out on decoding strategies? Because honestly, understanding this stuff completely changes how you look at AI.
And this is maybe the most important point of all. The AI's voice, its personality, its creativity, it's not some kind of magic. It's a choice. It's a direct result of which one of these strategies is being used. The difference between a bland, robotic answer and a genuinely creative one often boils down to just changing a single number, like K or P.
And knowing this really empowers you. Now you get why you sometimes get a boring answer from an AI. You see that the creativity isn't some accident. It's deliberately engineered into the system with these sampling methods. It just makes you a smarter user, and it gives you a much better framework for understanding where all this technology is going.
Which, of course, leaves us with a pretty big question to think about. These methods for writing are just getting better and better at sounding human. So as they keep improving, where exactly do we draw the line between human creativity and machine creativity? At what point does just being really, really good at predicting the next word turn into something more? Anyway, that's something to chew on. Thanks for digging into this with me.